forward to meeting all of you individually at some point. It's always a pleasure to be invited to present at the Board of Education meetings to discuss curriculum instruction and assessment. And tonight especially so, because I have the pleasure of introducing you to some fabulous teachers and their even more fabulous students. So without further ado, I would invite you to welcome three teachers from Wood Glen Elementary. Grade 1, Ms. Coulter, Grade 2, Dr. Straighton, and Grade 3, Mrs. McKinstry, and their students. They are going to spend a few minutes with you showing you how the mathematical units of study in our curriculum actually scaffold learning through the grades aligned to the learning standards.
Thank you, board members and community members. We are really honored to share with you the work we've been excited about in our classrooms and the work that our students have been equally excited about. And come on up, gang. We'll introduce all of our students first. Come right here. And you can share your name.
Eric. Neidhart. Sarah Weissman. Noah Blayford. Laura Bialik. Zach Nudell. Jason Gustler. Andrew James.
So last year I was a grade 1 teacher, and there are teachers from each of the grade levels that met together to work on the curriculum planning for really mapping out our instruction. And it was really rich work across the schools that I was honored to be a part of with so many terrific teachers in so many different schools here in the district. And from that, part of our website internally has the curriculum maps that have been made, as well as other resources that grew out of that work, such as parent letters and assessments that could be used formatively as well as summatively. And our school in all of our grades have been using those resources, which we think has been helping our students learn and helping our parents and teachers grow to be better instructors and to help our students as much as we can. In fact, on the next slide, you'll see part of what's on a parent letter from the first grade, sorry, one back, that helps parents to see the various strategies being used in grade 1. And what we wanted to show you today is how the work in grade 1 scaffolds to support our students as they move into grades 2 and 3. And that couldn't happen without the work that happened collaboratively at the district level across our schools, but also in our schools, the planning that takes place within a grade level and across grade levels. So Ms. Coulter and myself and Mrs. McKinstry have had the chance to work together looking at how can we help our students in each grade and what does it look like as we help students get to the next grade and the next place in their instruction. So let's see from grade 1 how that might look as we work on making new units. We make units of 10 in first grade, and we take from units of 10 as a foundational way to see and understand our number system.
Okay, so here we have Eric again. He's going to model 2 different strategies that they've learned to add in first grade. So on the slide, you see one example, 9 plus 3. So Eric is going to demonstrate one way to show 9 plus 3 using the counting on method. So Eric, first take your 2. Which 2? So why don't we explain our thinking, okay? Use your words. So,
I have 9 and 3 here.
So can you? Great job. Now he's going to count on. So we have 9,
10, 11, 12.
Okay, so that's one way that they learned to add in first grade. The new way we recently have covered is make 10. So now Eric is going to show everyone how to make 10. Explain.
Take 1 from the 3 and put it on the 10.
So now the new equation is?
10 plus 2.
And our first graders know their teen numbers very well. So if I ask Eric, 10 plus 2?
12.
Good job. On this next slide, we have 9 plus 8. So I'm going to ask Eric. Eric, which way is easier or quicker to find our solution? Counting on or make 10?
Make 10.
Can you please show the audience again how you are going to make 10?
Take 1 from the 8 and put it on the 9.
So your new equation is now?
10 plus 7.
Which is?
17.
Great job, Eric.
In second grade, students will continue that work to use in subtraction, so that if he was subtracting 7 minus 9, he could take it from the 10 and see he has 7 and 1 left to make 8. In second grade, we're going to use all of this foundation to make new units that are larger. So, Jason, if I have 189 plus 52, could you make another 100 in your head to solve that? Can you tell us the answer?
241.
How did you do that? How did you figure that out?
First, I made a number bond out of 52, 11, and 41. And then I did 189 plus 11 to equal 200, then 200 plus 41 to equal 241.
Awesome, thanks, Jason. We still teach the traditional algorithm and look at place value using place value discs, which are circles that show 1 or 10 or 100 to show units of each value. So Andrew, can you help us understand your chip model picture here?
So I drew my 189 with lines on the chip model. Then I drew 152 in circles. Then I look at my ones place, and I see if I can make 10 out of 10 of those ones. Then if I can, I circle the 10 ones and make a line to the 10th place and make another 10 in the 10th place. Then I look at my 10th thing and do the same thing, but with the hundreds, and you take 10 tens and put them in the hundreds. Then you just look at the leftover numbers that aren't circled, and your answer would be 241, as Jason said.
This is a concrete way for students to see that bundling work. And Sarah will explain how we can move towards the abstract method that we know as the traditional algorithm to solve the same problem.
So I did 9 plus 2 is 11. So I put the 1 1 with the ones and the 1 10 on the line under the tens. So I do 8 plus 5 plus 1 is 14. So I put the 4 ones there, and it makes it 4 tens. And then I put the 1 10 under the 1 in the hundreds. So I do 1 plus 1 is 2. And it becomes 241.
We'll see similar work in subtraction, and Jason is going to demonstrate mentally solving this subtraction problem, 115 minus 80. What is our solution? What is our answer to this problem?
35.
Tell us how you got it.
First, I made a number bond out of 115, and then I did 100 minus 80 to equal 20, and then I did 20 plus 15 to equal 35.
Thanks, Jason. We continue this learning again towards the standard algorithm. So you'll see in our next slide a picture of the work that Andrew did to subtract from 115 to take away 86. And Andrew unbundled to do that. And then we'll see the next slide, Sarah's work, where she used the algorithm and unbundled and showed that work in the way that's more typical as well, that we had learned as our standard algorithm. This work continues as we see students move into third grade and work on multiplication, because in the beginning of the year, our students know their 2 times table, their 5, sometimes they know their 3s and their 4s very well. And as they move on to the harder problems, which we'll see on the slide, these are sometimes out of what they know as their automaticity, their fluency of multiplication facts. But as you'll see from our third grade students, they can use that same work of looking at our unit and decomposing or composing units to solve these larger problems before they have them as automatic recall.
So if we look at the next slide, Zachary was shown this shape and asked you what the area is, and you came up with. So at the beginning of the year, 8 times 9 was kind of hard. So what'd you do to make it easier?
The 9 up to 5 and 4, and then I did 5 times 5, which equals 40, and then I did 8 times 4, which equals 32, and then I did 32 plus 40, which equals 72.
So it's 8 times 9?
72.
So Noah saw this shape, and what's the area of this shape? Can you say it again?
10 times 10.
So that was hard to figure out. How'd you make it easier?
I broke it up into 5 times 10 and 5 times 10.
Okay, and what'd you learn from that?
It was 50 and 50, and I added it together, and the sum was 100.
So 10 times 10 is?
100.
So Laura saw this shape, and the area is?
7 times 8.
And so 7 times 8 was hard. How'd you make it easier?
I broke it up into 5 times 8 and 2 times 8.
And what'd you learn?
5 times 8 equals 40, and 2 times 8 equals 16.
And when you add them?
56.
So it's 7 times 8?
56.
So hopefully that's just a quick snapshot of the deep work that's happening, not only in our grades when we collaborate together, but across the years. And you can imagine how that might even look as we move into fraction work in our older grades. Thanks for having us here tonight.